Welcome to our demo showcasing how Snowflake and SingleStore can work together to deliver real-time analytics with zero-ETL. So here we're looking at a ride-sharing dashboard built on Snowflake data, showing key metrics like the number of drivers available, ride requests, and the statuses of rides. Notice the timestamp in the corner, indicating that the last update was almost a full minute ago. Now let's navigate to this analytics page. On this page, we can dive deeper into metrics like average ride duration and wait times. The dashboard allows filtering by city and time frame, giving us a granular view of performance. As you look at the charts, you'll notice gaps in the most recent time frames, with empty bars. This is due to an ingestion lag of about 10 seconds. While real-time data may not always be essential for generating historical reports, it becomes critical when you need to make real-time business decisions. For example, in ride-sharing, the ability to adjust pricing dynamically based on the real-time availability of drivers and riders can have a direct impact on revenue and service quality. Now let's enhance the setup using SingleStore, a real-time SQL database that is now available to run within the Snowflake ecosystem as a native app. By clicking on the SingleStore logo, we're now querying data from a SingleStore instance running within Snowpark Container Services. Instantly, you can see that the latest update is much closer to real time. Going back to our analytics page, the gaps in the recent data have been filled, and updates are refreshing every 5 seconds. In fact, we can even refresh at a 1-second rate. This real-time data allows us to make crucial decisions like generating pricing recommendations for rides based on live supply and demand, and see how fast the dashboard refreshes upon changing the city. Now, how did we achieve the seamless integration between Snowflake and SingleStore? As you will see, we're leveraging SingleStore's native Iceberg pipelines to ingest trip data from Snowflake into SingleStore, eliminating the need for ETL and avoiding data export costs. We then combine this historical data with real-time stream from Kafka into SingleStore, where its powerful query engine performs millisecond analytics on both data sets. Now let's walk through setting up this integration step by step and building our own real-time dashboard. So we'll go ahead and open up our SingleStore DB app. And we'll create a new cluster. So we can give it a name and select the size. You can leave it on dev, and it will define a root password. Go ahead and hit create cluster, and this will spin up a SingleStore instance within our Snowpark container. Alright, now that our cluster has been successfully created, we will be able to retrieve information about the cluster here, including this connection URL that we will use to access our cluster from Snowpark. And at the bottom here in advanced, we're going to launch SingleStore Studio, which is essentially the UI to monitor the health of our cluster. So over here, we will click on SingleStore. We will then enter root as username, and then the password that you had defined in the previous step. So here we can monitor the health of the cluster as well as executing SQL queries against our SingleStore database. So we will run through some SQL queries that will allow us to create a database, create tables, as well as pipelines. And all of those SQL queries are also available in the GitHub repo. So we'll go ahead and create our database, our trips table, and an Iceberg pipeline to bring our Snowflake data into SingleStore. Again, no ETL needed and no egress cost. We will start the pipeline. And as easy as that, we have now ingested over 40 million rows from our Snowflake Iceberg tables into SingleStore table. So now let's go ahead and create some Kafka pipelines to ingest trip data in real time. So Kafka pipelines are also natively supported by SingleStore, and we will create 3 pipelines to consume from 3 topics. We will start all pipelines and running a debug query finally to see the current number of trips, riders, and drivers grouped by their status. So within just a few minutes, we were able to set up both Iceberg pipeline to ingest historical data from Snowflake into SingleStore, as well as Kafka pipelines to consume real-time data. And now we can use SingleStore's powerful query engine to perform super low latency analytics on top of this combined data. But we need to first deploy our app in Snowflake. Now that we have data set up in SingleStore, let's switch over to Snowflake and deploy our application that will be accessing this database. Again, all of this code is in the GitHub repo. So we'll create a compute pool and image repository where we'll be pushing our Docker image, and finally, our actual service. We will then get our public endpoint by running show endpoints, and we'll copy paste this URL in a new tab. And we see our beautiful dashboard. Now when we hit the SingleStore logo, we are querying against the SingleStore database that's running inside Snowpark, serving as this analytical engine that is ingesting and processing both historical and real-time data with millisecond latencies. And all of this without having to move anything outside of our Snowflake environment.